Hey, got a couple of PLCs to look at. They're both the same. They are from Digital Loggers, a company in California. I bought this one new and this one used. I actually got a really good deal. They were on eBay, separate listings, and I'll put the price I paid for each on the video here. And let's see the features here. Let's see, they are Atmega 2560, yeah, I think that's it, based processors. So the same one you have in the Mega, Arduino Mega. It's got an ESP8266 that is programmable also, and you can access it from the Atmega through a serial connection that's built, that's pre-connected for you. It's got a 2.4-inch TFT touch display, and it is SPI based. It's got 8 digital inputs that are opto isolated, and they can take in, let's see, what was it? It is 3 to 24 volts AC and DC. So that's a different thing. So, but they are opto isolated. You have 8 analog inputs that are scaled from 0 to 12 volts. Excuse me, 0 to 10 volts. And they do not have 4 to 20 milliamp support, current sensing support, but you can do that with a resistor. Let's see, what else does it have? 6 relays, and the relays are 20 amps max, which is pretty high, and they are fused at 10 amps. So the most you can go is around 10 or a little below, which should be adequate for most things. You have a built-in clock calendar that's battery backed up, extra 32K I2C EEPROM built in, SD card slot, sound output, and then it can be powered by 11 to 24 volts DC. So also has built-in DIN mount on there with your little sliders. And let's see, there's your USB port, your SD card, and here are some of your ports. Get it in shot here. Your analog, your digital, and your relays. And on the other side you have some more. This is your open collector right there, so you only want to sync things there. Your relays, and then RS-232 output. So this is not TTL, this is 232, and then the 1 amp fuse, and then your power. So let's turn one of them on. I'm going to turn this one on first. I've got a program I did on it that's just a simple demo. This has got the factory demo on it, and I've got it where it's toggling the relays on and off, and then also displaying that. So I'll shut up so you can hear. So there we go. Toggling them on and off, and writing on the display on and off. So not anything major there. So let's see, let's unplug that one. Okay, now we're going to move this one kind of out of the way here, and we'll plug this one up. And this one's got the factory demo on it. See, it'll take it a minute to boot up here. See it booting up.
Welcome, and thanks for choosing this easy-to-program open-source PLC.
It's got sound. That's using WAV files,
Wi-Fi, it's perfect for home
and it's using
automation,
a library
DIY
to
projects,
put it out
machine
through the
control,
sound,
lighting,
the
and
speaker,
more.
through
Use your
PWM.
imagination.
So
Let me show you around. Just press here to view the input status.
okay, so you can load, just loading the image files off the SD card. So I hit the inputs, and it'll display them.
There are 8 analog and 8 isolated digital inputs.
Possibly play around and get something to change here. Nothing, but anyway, so it shows the status of the analog and the digital. We'll go back.
Welcome back. Press here to control the relays.
Okay, go to relays. Now they're loading.
The relay terminals are rated at 6 amps and fused at 10.
Okay, so 6 amps and fused at 10. So this is just a graphic it loaded. So and it's writing text to it. And you can turn it on and off, turn the relays on and off. So nice touch. You know, that may be useful for a lot of things to control, especially if you're doing something where you're doing PID settings to get your reset, you know, all that done correct and on the fly. So be nice for that and other things.
The PLC also has 8 digital outputs, and it's fully compatible with the familiar Arduino Mega.
Yeah, that's true.
Visit plc.us for more information.
It's really not any major code for it. I mean, it's just, you know, what you would do in the Arduino environment.
And thanks for choosing
Okay, so we'll power this off now and move it out of the way. And now we're going to take this one and, well, get this fully out of the way. And I'll take this one and we're going to take the cover off. I've already loosened the tabs on it. It's got little push tabs, so I will unplug the LCD. It's not too hard to take apart. It's just kind of fiddly. And there we go. We'll just leave it like that. We can see what's going on here. Here, your relays. It uses a ATmega 16U2 for the USB interface. Uses one of the familiar boards you see like on AliExpress and eBay for power for your bucking. There's your, of course, your clock calendar, and here's your opto isolators, and probably some converters for the analog. Your ESP's right there, and again, it's connected to the Atmega via a serial. I think it's serial 2 in the Arduino environment. You have some extra pins that aren't accessed, or excuse me, broken out to here. So like these ADCs right here, so you could get to those if you need to. Just, you know, put a header on there and then pull them out. And then the same for these digital, which that looks like a 2mm pitch header. So, and there's 3 more there, so you got to get the 2mm pins for that. And then you got your programming interface for the ESP right here, and then your SD card there, USB. This particular one, I bought it used, and I don't think it was ever used in production. I'm thinking this is like a Kickstarter one, but the USB card was corrupted. It would work, but it was show garbage. The sound does not work on this one. Don't know why, but well, I'm guessing why. But other than that, everything else worked. The ESP works, the Atmega worked. But you have this guy right here. Let's see if we can get it in focus here. It was kind of melted there. If you look, notice this pin right here. Let's straighten it out a little bit. Notice that pin right there. It's kind of melted. There was no damage on the board. I've got another capacitor coming for it soon. It was a 1000 UF at 50 volts. I've got a 50 volt. No, that's a 50 volt. This is a 35 volt. Right, temporarily. It's for filtering, so, but I did want to put the proper capacitor in there before I use it. But other than that, it was okay. It worked, except for the sound, and then the capacitor. But they're well built. Even new, they're $150, so that might be within reason of a lot of people. But I got these. I paid less than $100 for both of these on eBay. It comes in a box. Let's see, get the box here. It comes in a box like this, and with some documentation and stuff like that. But the new one came in a box, but the second one did not. But it'd be probably a good thing for somebody that wants to do some type of industrial work without doing ladder logic or buying a regular PLC. There are other alternatives for PLCs for Arduino based type system or at ATmega, but they're more expensive, a good bit more expensive. Again, new, this is $150. You can possibly find them on eBay. I found these both at the same time. And I bought this one. And then when I bought it, I got an offer from the guy who was selling this one new. He had dropped it down because he wanted $100 for it. And he dropped it down, and then I offered him the same amount that I paid for this. He asked for $2 more, so this one I think was $43 shipped with taxes and everything, and the new one was for $53. So $10 difference between the two. So less than $100 for both of them again. So I'm planning on using one of them in my project that I'm working. It's going to be an outdoor project. And the other one I may use to change out the controller inside my CNC machine. So I may do that and be able to do some settings from inside the control panel. And so, but anyway, I haven't played with it too much. I wrote the little demo code that does the little flipping the relay and then right into the display. It wasn't hard. It actually uses the Adafruit display library for that. So no major hurdles for coding it because it's just using regular Arduino based libraries, the wiring type libraries. Looks pretty solid. It's touted as being open source. It's got the ESP. It's got the big Mega on there. Lots of isolation, lots of outputs. Built-in clock calendar. And ready, or at least semi-ready for industrial. It'd probably be better if you put it in a good shielded cabinet. That's just learning experience I've had over the years doing stuff with regular microcontrollers that aren't in really heavily shielded systems. You want to keep them kind of noise limited in a shielded cabinet. But anyway, I will kind of let you guys know as I continue with progress on this. And anyway, thanks a lot.